Hi guys, I Aziz welcome you to CoedMaster, and in this video I am going to talk about ArrayDeque collection class. In this video I will show you what is ArrayDeque, how it works, what are the features that are offered by ArrayDeque collection class, and what are the most commonly used method that we can call on ArrayDeque collection class. So please watch this video till the end. So let's get started. Alright guys, let's begin this video with this collection hierarchy diagram. So if you look at this collection hierarchy diagram, you will see that there are two collection classes that implements deque interface. The first collection class is linked list and the second collection class is ArrayDeque class. And the deque interface extends the queue interface. So this means all the methods that are available in queue interface as well as deque interface are also available in linked list collection class and ArrayDeque collection class. So this brings us to the question that what is the difference between linked list and the ArrayDeque collection class? Well, the difference lies in the implementation. So when we have linked list implementation of deque interface, the underlying data structure that is used in ArrayDeque implementation is linked list. And when it comes to ArrayDeque, the underlying data structure that is used to implement deque interface is dynamic size arrays. Now, if this is clear to you that what is the difference between linked list implementation and ArrayDeque implementation, then we can move on to the next question, that what actually is ArrayDeque. So in order to understand what is ArrayDeque, first we are going to understand what is queue, what is deque, and then we will understand what is ArrayDeque. So let's start with the queue. So what is queue? So queue is a linear data structure which stores and removes elements in FIFO style, and here FIFO stands for first in first out. So the element that is going to enter first in the queue will be removed first from the queue. So let's say we have a queue and this queue has one end from where the elements are added and there is one more end from where elements are removed. So this is all about queue. Now what is deque? So deque is also a queue, but it is an enhanced version of queue. Why enhanced version? Because it has two ends, and from both the end we can add or remove the elements. So let's say this is a deque and it has two ends. One end is here and the second end is here, and from both the ends we can add or remove the items. Okay. Now the question is, what is ArrayDeque? So ArrayDeque is a linear data structure which is a array implementation of deque data structure. So this deque data structure is implemented using array, and that is why we call it ArrayDeque. Now I hope you understood what is queue, what is deque, and what is ArrayDeque. Now let's move on to see how ArrayDeque actually works. So as we know that ArrayDeque is implemented by array data structure, so this is just a normal array, and on top of that we have implemented the features for adding the elements and removing the elements. So in case of ArrayDeque, we have two ways to add or remove elements. Either we can add or elements from the back, or we can add and remove elements from the front. Now on top of that we have one more advantage. As we know that ArrayDeque use dynamic size arrays internally, so what happens when array gets full? So in that case we do not have to worry about the capacity of the array, because the dynamic size array when gets full, then it automatically grows its size. So when this array gets full, it's going to create a new array whose size is substantially more than the size of the previous array, and then it copies all the elements from the previous array to this new array and then continues its operation like add and remove. So this is the main advantage we get when we use ArrayDeque, that the internal representation of the ArrayDeque, that is array, grows and shrinks its size as per the number of elements. And the cherry on the cake is, as the arrays stores all the elements in contiguous memory location, we get a random access support, so that we can access any element of the array in constant time. So this is how ArrayDeque internally works. Now let's see all the features that are offered by ArrayDeque. So first feature is, we do not have to care about the capacity of the ArrayDeque. Why? Because internally ArrayDeque uses growable array. So whenever array gets full, it grows and shrinks its size automatically. Now the next feature is, ArrayDeque does not allow null insertion. So if you remember from the previous video that in linked list implementation of ArrayDeque, null insertions are allowed. But in case of ArrayDeque, as it uses arrays internally, the null insertions are prohibited in ArrayDeque. The next feature is, the ArrayDeque uses two pointers, head pointer and tail pointer, and these two pointers take care of insertion and deletion of both the ends. Next feature is, ArrayDeque allows duplicate values. So these are allowed in linked list implementation also and ArrayDeque implementation also, that we can add duplicate values in the ArrayDeque. Now the next feature is, as the ArrayDeque uses dynamic size arrays internally, this means all the elements are arranged in contiguous memory location. So the access of first and last element takes only constant time because array has random access support. Now the next feature is cache friendliness. So because of the locality of reference, it is more likely to happen that the elements next to the first element or the last element are stored in the cache of the CPU, so that whenever you access the first and last element, you get the element from the CPU only. Your CPU do not have to make a round trip to a RAM to access the element. The next one is, we can use ArrayDeque as a queue as well as stack. So in case you want to use ArrayDeque as a queue, you can use it as a queue because it implements the queue interface. And if you want to use ArrayDeque as a stack, then you can also use as a stack because it implements deque interface. And deque interface has all the methods that is used to add or remove elements from both the ends. Okay. Now the next feature is, ArrayDeque consumes less memory than linked list implementation. And why is it so? Because linked list is made up of nodes, and if you look at each of the node of linked list, you will see that node contains three things. First one is data, and the other two things are the references to the previous node and the reference to the next node. So in order to store the references, we again need few more memory. Okay, so that is why linked in node end up taking more memory as compared to array element. Okay, in array element we just have to store the element at a specific location. That's it. We do not have to maintain the reference of the previous element and the next element. So that is why the array implementation takes less time as compared to linked list implementation. Now the next and the last feature is, ArrayDeque implementation using array is much faster than linked list implementation. And why is it so? As we know that all the objects are stored in heap memory. Okay, so let's say one object is stored here, and this object keeps reference of next object, and the next object is stored here, and the next object is stored here. So overall it takes time to access this element, then this element, then this element. But this is not the case with array. As the array's elements are stored in contiguous memory location, we can access any element in constant time. Why? Because array has random access support. So guys, these are all the features that are offered by ArrayDeque collection class. Now let's see the methods that are available in the ArrayDeque collection class. So the first methods we are going to see is the queue specific methods. So in queue specific methods, we have add, remove element, and offer, poll, and pick. Now add method is equivalent to offer method that is used to add the element at the end of the queue. Remove and poll method are equivalent, and these two methods is used to remove elements from the front of the queue. And element and peek method is used to see the element that is present in the front of the queue. Now the question over here is, what is the difference between add and offer, remove and poll, and element and peek? So the difference lies in the behavior of these methods. So for example, when you call add method when the queue is full, it's going to throw illegal state exception. On the other hand, if you call offer method, it simply returns false, and this false value indicates that the queue is full and we do not add more elements to it. Similarly, when remove an element method is called on empty queue, and it's going to throw no such element exception. Whereas if you call poll and peek on empty queue, it simply returns null. And here this null value indicates that the queue is empty. So these are all the methods that we can call on ArrayDeque when using as a queue data structure. Now let's move on and see all the methods that we can call on ArrayDeque when using it as a deque data structure. So here are add first and add last. These methods are used to add elements to the front of the queue and to the last of the queue or to the end of the queue. Remove first and remove last method is used to remove elements from the front of the queue or from the end of the queue. Okay. Get first and get last method is used to get the first element of the queue and get the last element of the queue. And all of these methods also throws illegal state exception. So these method throws illegal state exception when called on queue that is full. This method throws no such element exception when called on queue that is empty. And similarly, get first and get last method also throws no such element exception when called on queue that is empty. On the other hand, there are methods that are equivalent to all of these methods, that are offer first and offer last. This method is used to add the elements to the end of the queue or front of the queue. And these methods when called on queue when that is full, it simply returns false. and this false indicates that queue is full and we cannot add more elements to it. So the next one is the poll first and poll last method, and this method is used to get and remove the elements from the first position and from the last position, and in case of empty queue it simply returns null. Next one is the peak first and peak last. So this method does not remove elements from the queue, rather it simply get the elements present at the front of the queue and elements that present at the last of the queue or at the end of the queue. And when calling this method on empty queue, it simply returns null as a value. So guys, I hope by now you understood that what is meant by ArrayDeque, how it works, what are the features that are offered by ArrayDeque, and what are the most common method that we can call on ArrayDeque in order to use it as a stack or queue. So if you have learned something valuable from this video, then hit the like button in order to make YouTube algorithm happy. Please subscribe to this channel and don't forget to click the bell icon so my friend you never miss any upcoming video. So this is all from my side. Thanks for watching. See you in the next one.